Now let's look at this type of problem. Let's count the number of triples like ijk, where ijk they are integers and they must satisfy these requirements. I is less than j is less than k, and they're all greater than or equal to 1, and they're all less than or equal to n, but ijk, one is less than or equal to each other. The book provides the idea of using the n equals 5. Let's explain the idea so that you follow it. Now think about ijk, they can be numbers that like from 1, 2, 3, 4, 5, but ijk have to be in certain order. So for instance, let's look at one example like 2, 4, 5, this triple. You can think about, hey, this guy is chosen, so think about the n, 1 to n, as different categories. When n is 5, we have 5 different categories. Okay? When you see 2, 4, 5, that means you are choosing a 2. Okay, you are choosing a 2. And you're choosing a 4, right? You're choosing a 4, and then you're choosing a 5. Okay? So think about, I have dividers in between these categories, and each cross means the item that being chosen. So 1, 1, 1 means I have chosen 1 3 times, but I chose nothing from these categories. And 2, 3, 3, you can look at like 2, 3, and 3, and nothing else is chosen from other categories. So for instance, if I give you, say, I hope that you recognize what this result is. Suppose I give you that and that. Then you know this represents the number 1, 3, and 3. So what I'm trying to say here is every this combination here corresponds to a triple that satisfies this criteria. So how many possible triples that meets this criterion is the same as how many ways we can do this, right? And when you do that, that means we have 5 categories, meaning 4 dividers. And we have to choose 3 items from these 5 categories. So basically, the way we now can interpret is we need 4 dividers to separate these categories, and we need 3 crosses, and 1 cross represents each number to be assigned. Thus, we have total 7 blanks need to be filled. Okay, so therefore, how many triples that satisfy this requirement will be the same as I have 7 blanks to fill, as long as I place those 4 dividers once, then it's automatically determined. So it will be 7 choose 4. Now in general, the number of triples ijk when this is n, a general n, you can do that like how many dividers we need, n minus 1 dividers, right? And then how many crosses we need to how many items, how many crosses we need for these numbers to be assigned. We need 3 numbers, 3 crosses, and then m minus 1 dividers, and then we choose m minus 1. We'll just choose m minus 1 to place those dividers. Of course, when you write that as a so m minus 2 choose m plus 2 choose m minus 1 in general, okay, for this scenario. Now what if we have number of order, what if we want to find number of order 4 tuples here, where they are all less than or equal to 7, and they have to satisfy these requirements: I less than or equal to j, less than or equal to k, less than or equal to l. Now in this case, how many categories do we have? We have 7 minus 1 categories. Okay, I'm sorry, we have 7 categories, but we need 7 minus 1 dividers, which is 6 dividers. And therefore we have 4 tuples. That means we need 4 crosses here. So 4 plus the number of dividers, which is 6 actually. Okay, choose 6. Choose 6. Okay, so therefore to answer this question will be 10. Choose 6. Now you'll be surprised how this method can be continued to use in different situation. Let's take a look at the next problem. So oftentimes when you write program, you have this kind of nest. Okay, so k from 1 to n, and then for j from 1 to k, right? And then for I from 1 to j, and then there's some statement to be executed. And the question is how many times this statement will be executed. So I hope that you can see that this first statement is considered as k less than or equal to n. The second one you can see that as j less than or equal to k. And the next one you can see that I is less than or equal to j. And by the way, they're all greater than or equal to 1. So this is really just same as this will be how many this statement will be executed is the same as finding how many possible ijk's are there so that this is true, right? So this problem will be the same as finding possible triples of ijk where this is true, because for each different ijk this statement will be executed once. So how many times this is executed? This is the same as finding how many possible combination of the ijk where they are satisfied these requirements. So therefore this problem can be answered by, okay, first let's find how many dividers. So there will be m minus 1 dividers. So m minus 1, this is your dividers. And then plus, we have 3 letters here. Okay, so that's corresponding to 3 crosses. Just like the crosses here, representing which category you are going to choose. And then choose m minus 1, that's the number of dividers. So this is how I would solve that one. Now let's look at, extend the idea to some other scenario. Again, I hope that you will find it surprising or amazing how this technique can be used to solve so many different types of problems. So now let's take a look at this problem. Let's find the number of integral solutions for this equation, x1 plus x2 plus x3 plus x4 equals 10, where x1 to x3 they are just non-negative integers. That means they are greater than or equal to 0. Okay, xi greater than or equal to 0. Now, if you do not link this problem to what we have learned, the idea of what we have learned, and it can be overwhelming. However, now think of this x1 as the number of apples, okay, number of apples, and think of this x2 as number of oranges, okay. This is number of pears and this is number of bananas. So just put that into some context. Say how many ways can Jacob buy, say 10 fruit items, where those fruit items are coming from these 4 categories, and x1, x2, x3, x4 represents the number of fruit items from each category. Then you can solve this problem easily, right? So therefore you again think of like Jacob buying 10 fruits from 4 categories, right? So in this case, the answer is now you can just think about there are 4 categories, so therefore I need 3 dividers, right? And there are 10 fruit items, I need 10 crosses, so 10 plus 3, and then choose 3 dividers. So the answer is just 13 choose 3. So that will be how many integral solutions for this equation. Let's extend this one more time, okay? So find the number of integral solutions for this equation. Hopefully you are, by the way, this is x3, sorry, where x1, x2, x3 are non-negative integers. So this time, just I hope that you can pause the video if you want to try. But now this is very similar to previous one. So think of there are 5 fruit items to buy and coming from 3 different categories. So therefore you have to have 2 dividers and then 5 crosses to represent those fruits. So which will be 7 choose 2. And what if each integer is at least 1? So what are the possible number of integral solutions when x1, x2, x3, they're at least 1 or higher? So this is the same as saying just think about Jacob buy at least 1 of each, okay, at least 1 of each. So in other words, so at least 1 of each, that means 3 fruit items are automatically determined. So only 2 remaining, right? So only 2 remaining to determine, right? To determine. So therefore, I need how many dividers? There are 3 categories. I still need 2 dividers. But this time, 2 remaining plus 2 dividers. Okay. So therefore, 4 choose 2 will be how many solutions, integral solutions for this equation when each integer is at least 1. Alright, I think this is the end of this section. I hope you enjoy the skill that you learned from this section. I believe that the skill of counting will be in the next level after you learn this stuff.